In this video, we'll go over limit as x approaches pi of sine of pi minus x over pi minus x. Notice that we are going to use L'Hopital's rule to solve this problem. If you're interested in the solution using substitution or squeeze theorem, I'll leave a link to that video. So let's get started. Remember that if you're thinking to apply L'Hopital's rule, you gotta have indeterminate form. That means whenever you're trying to solve a limit, you gotta have 0 over 0 or infinity over infinity. Otherwise, you cannot apply L'Hopital's rule. In this case, when we plug in pi, you got sine of pi minus pi, which is going to be 0. And pi minus pi in the denominator, it's going to be 0. So you're going to get indeterminate form. What does it mean to us? That means that we can go ahead and try to solve this problem with L'Hopital's rule. Now, L'Hopital's rule itself states that if you get indeterminate form, you can find the derivative of numerator and denominator. So notice that we're taking them separately. You do not use quotient rule to do that. So we're going to take the derivative of sine of pi minus x and pi minus x. What is the derivative of sine of pi minus x? Well, it's just cosine of pi minus x. And remember that we have to use the chain rule because we have this function. We don't have a constant, unfortunately. So we multiply that by the derivative of whatever is inside. And what is the derivative of pi minus x? Pi is a constant, and we basically have just minus x, and that's going to be -1. And in our denominator, you don't even have to think about what are we going to put there, because you just solved this part, so it's going to be -1 again. That's going to cancel out. Now we can try to solve that limit again. So what is the value of cosine as x, cosine pi minus x as x approaches pi? What is cosine of 0 in this case? It's just going to be 1. So therefore, the answer for this limit is 1.